As we've discussed before, moment is equal to the force times the perpendicular distance between the force and the point of rotation. No moment is produced if the force's line of action passes through the point of rotation. For example, let's look at the beam. We have two forces acting on the beam at point B and C. Let's examine how these forces create a moment about point A. If we draw the lines of action of each force, we can see that they do not pass through point A, since the forces are not perpendicular to the beam. We must consider the x and y components of each force. Before we begin, we should always establish our coordinate system first with right, up, and counterclockwise as our positive direction. Then we can draw the x and y components for each force. When drawing the line of action of each x and y component, we can see that the cx, cy, and by do not pass through point A. However, the line of action of bx does pass through point A, which means that cx, cy, and by will create a moment about point A, but bx will not. Let's talk about the rotation of each force. Remember that we're not including bx as its line of action passes through point A, which is the point that we are taking the moment from. As you can see, by will cause the beam to rotate in a clockwise direction around point A, creating a negative moment. Cy will cause the beam to rotate in a counterclockwise direction around point A, creating a positive moment. And finally, cx will cause the beam to rotate in a counterclockwise direction around point A, creating a positive moment. In order to calculate the total moment about point A, you can solve it two different ways. The first way is using the moment equation, which is equal to the force times the perpendicular distance. This means that you would be using the x and y components. The second way is that you can use this equation. Moment is equal to the force times sine theta times d. F is the magnitude of the force, theta is the angle between the force and the beam, and d is the distance between the force and point A. The second equation does not require the x and y components of each force. For an example, let's call the horizontal distance from A to B 4, the horizontal distance from A to C 8, and the vertical distance from A to C 2. Using the first method with the x and y components would look like this. The moment about A is equal to 0 in equilibrium, which is equal to negative by as it's in the clockwise direction, times the perpendicular distance, which is 4, plus positive cx as it's in the counterclockwise direction, times the perpendicular distance, which is 2, plus positive cy as it's in the counterclockwise direction, times the perpendicular distance, which is 8. Using the second method, we would get the moment, which is equal to the magnitude of force B, times the angle between force B and the beam, sine 40, times the distance between force B and point A, 4, plus the magnitude of force C times the angle between force C and the beam, sine 30, times the distance between force C and point A, 8.